Welcome back. Today we will talk about network planning. The learning objectives for today's lesson are to understand the different kinds of planning for the energy infrastructure. There's also a relation with the motivation of the different actors and the possible interplay between them. Moreover, we will show the dilemma of network planning. In general, with respect to planning, one can distinguish between projects with a short realization period and projects with a long realization period. Customers and generation companies want to access the electricity grid, but they do not want to be bothered by the network operation. Customers need reliable and available supply at an affordable cost. Renewable energy generators want to make money by investing in solar panels and wind farms, and for this they need the grid. However, network companies need to develop the network, and here comes the problem. The time horizon for planning network infrastructure is much longer than the realization time for energy projects by consumers and generators. Energy projects can be realized in a few years, but network reinforcements may take much more time. Industrial companies and renewable generators can freely enter and exit the market. The lifetime of wind turbines is 20 years, and for solar panels up to 30 years. But the lifetime for the electricity grid is 50 years or longer for most of the components. So network planning is a long-term issue compared to generation planning. The network is the enabler for future economic activity, and having wider network access will attract new investments. Network planning is also an iterative process. Network companies start with an overall view of how many transports are necessary for the consumers, and how much access is needed or how much network reinforcement is needed. Since network planning is a long-term issue, network companies regularly make demand and generation projections to identify the spots where the grid needs to be enhanced. This demand for network capacity forms the basis for network design. In order to implement the design, we need to secure sufficient investment to be allocated for the execution of infrastructure projects. This is the final step in the cycle, and then we start all over again with the status quo. There are all kinds of planning aspects related to the energy networks. On the national level, we have the policy ambitions that mostly deal with how much load is expected in each location, how much electrification for electric vehicles are desirable, and what sources will be used for space and industrial heating. But there are also policy targets related to the minimum amount of renewable electricity generation. Then there's also the regional level. European countries have open access to the network. This involves cross-border trade and transports. So countries have to agree together on the planning procedures that affect the energy flow from one country to another. Sometimes regional planning also specifies the type of infrastructure to be built and the required level of interconnection between countries. So once it's known what infrastructure is needed, be it gas pipelines or electricity transmission lines, the execution of these projects needs to be authorized by the local and regional planning authorities. For this, there's need for coordination with the local authorities. Also, the actors that might be affected by these projects need to be involved in the planning process. Therefore, the local level is more concerned with the project plans and specific details, like in which street what type of infrastructure will be realized. Summarizing, starting from the high-over policy ambitions to the local, detailed project plans, the amount of detail increases at a lower level. The high-level ambitions are generic and often not very specific. As indicated before, there's often a planning dilemma. The main problem is the difference in planning horizon. Planning of new wind farms or solar parks is something rather quick. It takes only a couple of years and then it's operational. Whereas network planning, needed for the connection of the solar parks and the wind farms to the grid, is not only costly, but more time consuming. The higher the voltage level, the longer the required period for implementation. So here is the planning dilemma. There is a time difference between what clients want and when, and what the network company is able to facilitate on such a short notice. If clients decide to invest in a solar plant, for example, it may be in operation in 2 years. But if there's insufficient network capacity, then the network company needs to develop his network. But this may take easily 5 to 10 years. So when does a network company take the decision to expand the network? Well, there are two options. The first option is to wait with network reinforcements until there pops up a client initiative. Only after a request is made to connect, for instance, a solar park. We call this ex-post planning. Ex-post means after the event of requesting the connection. The alternative is that the network company acts proactively and starts to reinforce the network before there is any client request. We call this ex ante, which means before the event. Each of the two strategies has advantages and drawbacks. When network companies choose to wait for the client initiative, they make sure to invest in a profitable project that is really needed and used by the client. However, the drawbacks are that the implementation takes longer. In the meantime, there is the risk of congestion in the network if the client is connected before the reinforcement of the grid backbone is realized. If the client has to wait, there might even be a risk of having undersupply generation if there is a capacity shortage. If the second strategy is followed, the network company just starts to expand the network based on where the network company expects the demand to come. The network is then developed faster and the risk of undersupply and congestion is reduced. But now, of course, there is the risk that the clients will not come at all, and hence the network will be underutilized. The cost for the network reinforcements have to be paid by other consumers. This planning dilemma can typically be solved by some kind of regional planning by the local authorities. When authorities develop plans for the future energy infrastructure in a specific city or a specific region, network companies may start to proactively act and invest. Of course, the regulatory approach is also important because if the risk is completely on the side of the network company, it will not be reimbursed for these investments if there are no additional clients. This may incentivize the network company to act in a risk-averse way. The regulatory regime should therefore support and facilitate such a proactive planning approach. In general, there is a need for public planning and also guaranteeing some sort of comfort for the network company in order to anticipate future developments. In principle, this can be done by implementing appropriate regulatory procedures. If these are not present, then investments in the expansion of the existing network for electricity or gas may be too risky and the network investments will lag. This will cause delays in the realization of new renewable energy projects. And of course, if there is a kind of urgency for the energy transition, this may pose severe problems.